let's look at question number 11. It says here, item 11 refers to the following information on the description of these three sets. We have set P, which is prime numbers, set Q, which is odd numbers, and set R, which is even numbers. So it says, which of the following sets is empty? Empty means a null set or set that does not exist. So what we need first to do, we need to list out what is set P, the prime numbers. Prime number are numbers that only have two factors, one itself. So the first prime number is 2, which is the only one that's even. So you have 2, 3, 5, 7. We just listen just a few of them. Q is what? Odd numbers. First odd number is 1, and you have 3, 5, 7. And the set R is even numbers, and those numbers that are divisible by 2, like numbers like 2, 4, 6, 8. So the question says, which one of them does not exist? Let's look at this first, option A. This is the intersection sign. That means what it has in common. P intersect R. What does P and R have in common? Let's look at our list here. P and R actually have 2 in common, so that's possible. Option B, we have P union Q. This symbol means a union, which means to put together. So we can put all of the elements of P and Q together. That's actually possible. Let's look at option C. P intersect Q. That means what P and Q has in common. P and Q, what do they have in common? They actually have 5 and 7. So that's possible. Let's look at option D. Q and R. What does Q and R have in common? Q intersect R. Q and R actually have nothing in common. It's totally impossible. So definitely D would be the empty set, the set that does not exist, or that's impossible. Alright, let's look at number 12. Number 12 is another set question. It says, if P and Q are 2 sets where this little n is the number of elements, the number of elements in P union Q is equal to 13, and the number of elements in P intersect Q is equal to 6, the number of elements in P is equal to 9, then the number of elements in Q is equal to what? So we're going to work this out. But first of all, we need to know the formula for this. Now the number of elements in P union Q is actually equal to the number of elements in P plus the number of elements in Q minus the number of elements in the intersection of P and Q. So if we want to find the number of elements in the union of P and Q, we'd have to add up the number of elements in P plus the number of elements in Q and subtract the number of elements in the intersection. But what I'm going to do now, I'm going to make Q here the subject. So what I'm going to do, I'm first going to carry over this negative number of elements in P union Q and make it positive. So let's carry it over the equal sign. So we're going to write back over the number of elements in P union Q plus the number of elements in P intersect Q. Remember, the number of elements in intersection was negative. When I carry it over, it turns positive. Another thing I could do, the number of elements in P here, if I carry that over, that turns negative. So that's negative the number of elements in P, and everything is equal to the number of elements in Q. So what I did, I just transposed to be the number of elements in Q by itself. So let's substitute our values. So early on in our question, it says the number of elements in the union is 30, and the number of elements in the intersection is 6, and the number of elements for P is 9. So the number of elements for the union would be 13, the number of elements for the intersection would be 6, and the number of elements for P would have been 9. So what I'm going to do, I'm going to use these values to find the number of elements for Q. 13 plus 6 definitely is 19. 19 minus 9 gives us 10. So our answer would be B, which is 10. Alright?